Hello, today's coding game is using a stack to reverse a string. So the goal is to build a function that has a parameter that is a string and a parameter that can hold the same length string. And the goal is to take the first string and reverse the characters and store them into the second string. And for this implementation of it, I'm going to use a stack. And so I already have some stack code that we have built in a prior video. We're going to use that, and the idea is take all the characters and push them onto the stack, and then pop the stack into the reversed string until the stack is empty, and then the resulting string will be reversed. If you find this video useful, please like and subscribe to help other people find it. Okay, I'm going to start this game with a CLion project. And the only things that I have put in the CLion project are the code for my stack and tests for that. If you want to know more about this code, I will put a link to the video that explains this code in the description. So to start, I want to make my CMake. See how the stack code is complaining that it doesn't belong to any project target? I need to make my CMake list know that it's there. I could have let it just fix that warning at the top, but I'll put them there. And that, when I reload that should make that warning go away. Yep, okay. Just to make sure that I have stuck everything together, I'm going to say, I'm going to create a teeny tiny little stack. I'm going to push something on it, pop it off, and make sure that I get back what I get. Not because that's part of the task at hand, but I'm just making sure that all of this stuff is hooked together correctly. So my stack is an array of characters, and I'm going to say it has 10 spaces in it. I should make that a constant, but this is just play. It's just temporary code. And I need to make my stack top start at -1. If you want to know why I did all of that, check out the video. There's a whole series of videos about how stacks work and then how we code them in C. I will put that whole list of videos in the description. So the first thing I want to do is push and I'm going to let it import that. Go ahead, give it back to me again. Yeah. And I want to push, and I don't remember the order of the parameters for push. The item, the stack, the pointer to the stack top, and the size of the stack. Okay. Push the item, the stack, the pointer to the stack top, and the size of the stack. So just as a quick review of what we're doing with a stack, with this particular code for a stack, I need to push an item onto a stack. For this implementation of a stack, I push in the item. The stack is an array, and we are keeping track of how full the stack is, or where the top of the stack is, with an integer that is always the index of the next place that you would put something into the stack. So we started at -1 because the first place that you put something is position 0 of the stack. I have to pass the address of my stack top into push because push needs to be able to change the value of my stack top. And then I have to pass in the size because C doesn't know the size of an array, and we need to make sure that we never push beyond the end of the array. And that's what the result here is for. Push will return true if it was able to do what it was supposed to do, and it'll return false if the stack was full, and therefore it couldn't do the push. So at this point, I should be able to assert that result is true. And I'll import that. that symbol. No, import it. Yes, thank you. And then I should be able to do the pop. I need a character variable for it to be able to put what it pops into. And then I'm going to say result equals pop the stack pointer. Okay, pop my stack, the address of my stack top, and the address of popped. So that third parameter is an output parameter. So pop is going to do its work, and the thing that it gets off the top of the stack is going to put into popped because it's going to chase that pointer and store it into this variable. And again, result is going to return true if it was able to do it, and it'll return false if you try to pop an empty stack. So at this point, result should still be true, and popped should be the M. Oh, 2 equals. There we go. The M that I put on. So all I'm doing is pushing an M onto the stack and then popping something off the stack. I'm checking to make sure that both of those operations say that they worked and that the character that I got back was in fact the M that I pushed on. This all should work beautifully. And it does. Exit code 0, so none of the asserts failed. Again, all that did for me was make sure that everything was hooked up and gave me examples of what push and pop look like when they work correctly. So now let's go back to what was the original problem. The original problem is I want to make a function that, given a string, will return a string that is the reverse of the string that it was given. So that would look like this. Jar pointer reverse. We're going to pass in a jar pointer that is the string. Jar pointer result. I want this to not return. Well, I want it to return a Boolean because maybe it works, maybe it doesn't work. And we need to talk about that pointer thing, don't we? So the way that I want to use reverse is I want to say result equals reverse AB and pass in, I want an output parameter that is a character pointer. Oh, I can't name it. The same thing reversed is what I meant to say there. And I want that character pointer to be an output parameter of the thing, so I want to pass in the address of reverse. We haven't talked about character pointers, and I think that makes this too complicated. Let's say you have to put in, so I'm going to change this to that. Str equals AE. Str equals AB. And then I'm going to make the reverse string, I'm going to allocate the space for it here. If I were to allocate the space for it up here, because we haven't yet had malloc, I would be returning a pointer to a local variable, and we've had long discussions about why that's a bad idea. So instead, I'm going to pass in the whole amount of space that it needs, and it needs to be an array that is the length of str. Yes, please go get that. Okay, so since I did that 6 different ways, let's review. The way that reverse is going to work is you pass in a string and you pass in a character array that is big enough to hold the reverse of the string, which means that I have to add the space for the null terminator. That's why I've just added that plus 1. And reverse should take this AB and put it into reversed and make it be BA. And so after I do this, result should still be true because it shouldn't fail. And I should have a B in reversed. No, I should not. I should have BA in reversed because it should be backwards from what I passed in. So if the first thing I do is I just make reverse return false, this should fail on line 25, which it does. I can make that one pass by, and now it fails on the string compare because reversed does not have the opposite of AB in it because I didn't make it do that. But now I can do this, reversed sub 0 equals the character B, semicolon. Oh, this is supposed to be reversed. Reversed sub 1 equals the character A, and reversed sub 2 equals the null terminator. So now I just by hand built the thing that is reversed because I'm trying to get this test down here to pass. Woohoo! Okay, now that's clearly not the way that I'm going to do it for real because I need to be able to pass in an arbitrary string and reverse an arbitrary string. So let's make another test down here. Oh, we can just say, oh, that we'd never be able to tell there. Oh, I like this line of code. But I'm going to have to rename, I can't name it the same variable. So I'll say reverse 2. And it failed on the string compare at line 34. It failed on this, which is exactly what we would expect. Why is it mad? Oh, it's not a word. You're right, it's not a word. Okay, so now the thing that we're passing in is complicated enough that I can't just like hard code the result. I mean, I could. There would be other ways to do this, but the way that I want to do this to show you how you would use a stack in this particular situation is what I want to do is I want to create a stack that is big enough to hold half the whole string, push them all on, and then pop them all off. And the result of popping them all off, put it into the string. That's just gibberish. There's way too much talking here. My strategy is, this is a good way to do this. Let's do my strategy is create a stack big enough to hold string, and then push every character in the string onto the stack, starting at the first one. And then pop the stack and store the popped characters in order, in reversed. So if you think about what that does, you take string and you push all of the characters on the stack. The thing that's at the top of the stack will be the very last character of the string. So I pop that out and I put it at the front of reversed. And then I pop the next one out and put it in the next position in reversed. So that's why the string is going to end up backwards. All right, so to create the stack big enough, I'm going to say I have a character reversing stack that is an array that is sterling of string. Okay, and I need a stack top that is -1. Okay, so then I want to push every character onto the string. So I think I'll do it with I'm going to treat the string, the character pointer, like it's an array. And I'm just going to do a walking through the array kind of loop. Push strings of I onto the reversing stack with the reversing stack top. Oops, that was supposed to be the address of it because it's a pointer. And the size of the stack is sterling of string. Why is that upset? Narrowing from unsigned long. Oh, okay. Sterling doesn't return an int, it returns an unsigned long, but my parameter says that it's an int. I'm just going to force the type conversion to make the warning go away. I know it's never going to be too big to fit in an int. Okay, so I have pushed the entire string onto the stack. Now I need to do the same kind of loop here. But every time I do it, I want to pop the reversing stack, the address of the reversing stack top, and the address of reversed sub I, because that's where I want to put it. Okay, I kind of like that code matches my general strategy. The bad thing I've done is I haven't paid attention to the fact that these two can return failures. So I'm going to say if that returns false, then the whole thing should return false. And similarly, if that returns false, everything should return false, because if any of the pushes or any of the pops fail, then reverse fails, and we need to tell people that this is not going to have the right data in it. If we get all the way to the end of this and all of the pushes worked and all of the pops worked, then everything seems to be fine, so we should return true. Just makes good sense. Now, because I allocated the stack here, the only reason that these things could go wrong is if we try to push on a stack that's already full, or we try to pop a stack that's empty. Because I allocated the stack, I know that it's big enough, this push is never going to fail. And because I'm only pulling this many things out of the stack, I know this pop is never going to fail. So technically, like, these falses should never ever happen, and this should never ever return false. But it's good form to define your functions consistently. I have made push and pop return true or false if they fail. And so it makes sense that reverse should similarly return true or false, depending on whether it has failed. The fact that this particular implementation of reverse can't fail doesn't mean that there isn't some other way I could write this code so that it could fail. So for consistency, I like, if I'm going to have my functions return true or false because they worked or they didn't work, then I should do that consistently here as well. Let's see if that makes our test pass. No, it did not work for BA. It didn't work for the first possibility. Huh? Fascinating. Let's put a breakpoint on the reverse of that. And here we are. We have an empty stack because stack top is -1. Stir has AB in it, just like we would expect. So if I step into reverse, here we are, step over that line. You can see reversed is, the space is allocated, but it has nothing in it. And stir has AB in it. So I step over and create my stack, and my stack has space for 2 characters, which is exactly right. I set the stack top to -1. I push the first thing, and if we look at reversing stack, the A went onto the stack. And then I push the second thing, and the B went onto the stack. And then that loop finishes. So that seems to be doing exactly what I would expect it to do. I'm going to open up reversed so we can see what's in it. If I step over the pop, I see the B go into reversed, and then you can see there's this other, like, just noise in it. Oh, now I know what the problem is. I did not put anything into reversed, so there's gibberish after it. So if I step over my pop, again, you can see the BA is there, and it thinks I'm finished. The problem is that there's no null terminator on that string. So when it comes down to here, to do the comparison of BA to what's in reversed, sorry, something's in the way. BA is not, BA and gobbledygook is not going to match BA with a null terminator. So this assert is going to fail. So the piece that I didn't do was I didn't put the null terminator after I popped everything off the stack. So let's terminate the debugger and go up here and fix our strategy. Put a null terminator at the end of reversed. So reversed sub sterlen of string +1 needs to be \0. Now I have a null terminator there. If I, ooh, it still didn't work. Fascinating. This is so cool. Debug. And for a minute, I'm just going to step over and watch reversed does not have my null terminator. Why does it not have my null terminator? Sterling a string is 2. Oh, I put it too far away. It should not be 1 more. Sterling is 2 because it is the number of characters in the string. And you can see, because we're numbered from 0, the null terminator should go in position 2, not position 2 plus 1. So let's run it again. Okay. That's better. Woohoo. Now this one worked. But something is wrong with this one. Oh, I can see how this is grayed out. That is CLion telling me you never used this variable. Why did you do it if you never used this variable? I should use this variable here. And I need to call reverse. Oh, and I should spell that a little better. All right, are we good now? Yes. Ooh. Then the only other weird thing that I would do is, and it won't, the algorithm that you're using, this should not make a difference. But when you're reversing things, sometimes the fact that a string has an odd number of characters will make it reverse differently than when it has an even number of characters. In this case, it shouldn't make any difference at all. But just to be really careful, I'm going to add another character there. Reverse 3, reverse the string into reversed 3, and then reversed 3 should be C, B, A, B, A. Woohoo! All right, we have built reverse using a stack.